In this ACT video, we're going to take a look at the basics of polygons. So here are some facts about polygons. Not everything is a polygon. It must meet some certain criteria. And first of all the sides must be straight segments. It must be straight segments, not have any curved pieces. Okay, all straight lines, straight segments. None of the segments may overlap. There's no overlapping. Polygons are named by the number of sides, and a regular polygon has all sides and all angles of equal measure. Okay, so we'll look at some of these. Let's talk about the names first. I've got them listed here for you. The first column, these are your number of sides, and the second column is the name, and then I also have a little picture there for you. So with 3 sides, that's a triangle. Okay, all the sides are straight, no overlap, and there's also no gaps. No, it's completely closed figure. That's important also. If you have 4 sides, we call that a quadrilateral. So that prefix quad means 4. And likewise with the triangle, that prefix tri means 3. Now we're going to look more specifically at quadrilaterals in a separate video. This looks like a square possibly, but we could have anything. We could have a rhombus, a parallelogram, a rectangle. It just has to have 4 sides. 5 sides, we call that a pentagon. Okay, so that means 5. And there's a nice picture. And 6 sides is a hexagon. 7 is a heptagon. That one starts to get a little challenging to sketch if you needed to draw it. 8 sides, octa means 8, like an octopus. And so that's 8 sides. It looks like a stop sign. I did that intentionally with the red. And 9 sides is a nonagon, and 10 sides is a decagon. And that deca, means 10, like decade has 10 years in it. And then anything else, like if you had like 15, that would be a 15gon. Well, you might see a 12-sided figure, and that would be a dodecagon. I'm not going to attempt to draw that, but it would have 12 sides. So let's take a look. It's important to know the names because if you're asked about the measure of an interior angle or even an exterior angle, if you don't know how many sides you're dealing with, then it's going to be difficult to figure this out. And there's a little formula that we use to find the sum of the interior angles of any polygon. And that's this formula right here, n minus 2 times 180, and that n is the number of sides. So that formula is used to find the sum of all the interior angles in a polygon. We already know that in a triangle, all 3 angles add up to 180. And basically what's happening with any of these other polygons is we're cutting it up into triangles. So for example, an easy way to talk about this before we do our first example is just to look at maybe some quadrilateral, maybe a rectangle. That looks like a rectangle. Those are right angles. And if we draw one diagonal here, we don't want to draw any diagonals that intersect each other. Then now we have 2 triangles. And so 180 plus 180 gives me 360. And you can figure that out because that's 90 and 90 is 180 plus 90 is 360. All right, and to use the formula with a quadrilateral, n would equal 4. And so to plug that in, it would just be 4 minus 2 times 180. 4 minus 2 is 2 times 180, and we still get 360. So this comes from dividing up your polygon into triangles. So here's our example. We have got an octagon, and we want to find the sum of the interior angles of an octagon. Now let's just assume that this is a regular octagon, okay? If it's a regular octagon, then each one of these angles is exactly the same measure. Now, if it's not a regular, we can still use the n minus 2 times 180 formula, We just can't figure out which each one of these angles would measure. All right, so in this case, n is 8 because an octagon has 8 sides, and our formula is n minus 2 times 180. Oop, there we go. We'll do it that way. And we'll plug that in, so that's going to be 8 minus 2 times 180. 8 minus 2 is 6 times 180, and 6 times 180 is 1080. So that's what all 8 angles add up to. And that's what this question is asking. Find the sum. But let's take it a little bit farther, because if this is regular, if we assume this is regular, then we can actually take 1080, we can divide it by 8, and that will give us the measure of each angle. Each interior angle measures 135 degrees. That's only if this is regular, though. Now, I'm not going to go fill all those in, but you get the idea. And we can take this one step farther. You might be asked about the exterior angles. And what you can do to find the exterior angle, for example, this right here is an exterior angle. If you'll just extend your sides, the interior angles and the exterior angles, just go all the way around the figure. The interior and the exterior angles are supplementary. So you extend those sides, and you just want to go one direction, either go clockwise or counterclockwise, but you get the idea. And so if they're supplementary, I just need to say 180 minus 135, and then I can get an exterior angle of 45 degrees. Okay, so it's all about this n minus 2 times 180, and that gives you the sum of all the angles in the figure. And then if it's regular, you can go from there and find each individual angle.